Now, electric circuits can actually be connected in different ways. So here are two ways that electric circuits can be connected. The first way is called series, and the second way is called parallel. Now, basically, if you connect an electric circuit in series, it means the loads, the parts of the circuit doing the work, are connected in a line. So, along this straight line, there's the two light globes. They're in series. They go one after the other. The other way is in parallel. So these two light globes here, they're one on top of the other. The wire has to split here to go through both of these two light globes. And when we draw these as electric circuit diagrams, this is a bit clearer. So these two light globes, they're in series, means they're in a row, and in parallel, parallel, one right above the other, those are both in parallel. So you can see that those two light globes, they're connected differently in those two circuits. Really importantly, when we think about the way that they're connected, if we look at actually the battery involved there, that can tell us quite a bit about what's actually going to happen, how those different circuits are going to behave. So let's say this battery here is a 6 volt, 400 milliamp battery. And I've got two of these batteries here. I've got one over there and one over here. So 6 volts, 400 milliamps. So what's going to happen here in the series circuit is the current is going to flow along. Current can only go in one direction. This is the current. It's going to flow all the way around, and it can only flow on that path. So the current on both of these globes is going to be 400 milliamps, and it has to be because there's no other place for the current to go. But the voltage, so kind of how much energy the charged particles give each light globe will actually get, they'll split it. So if there's two, they'll get half each. So this light globe will get 3 volts, and this light globe over here, this will get 3 volts. So they'll both get the full current, but they'll split the voltage between them. So they will glow, these light globes, but they'll split the full voltage of the battery. So maybe they won't glow as brightly as they possibly could. Whereas in parallel over here, when we think about what's going on, we can see that the current has to split. So the current has to split between the two light globes. So this light globe will get only half, again it will split, half of the current. And this light globe at the top, that'll get only half of the current. So half of 400 milliamps is 200 milliamps. So both of those light globes will get half of the current. And of course, when the current joins back together here, a full 400 will flow back into the battery. So 400 leaves the battery, it splits here to go through the two light globes, joins back together, and then flows back into the battery. On the other hand here, the voltage of each light globe, each charged particle will give the light globe, as each particle goes past this light globe, it will give it its full voltage, the full energy. So each of these light globes will actually get the full 6 volts. So in a parallel circuit, the globes get the full power of the battery. And this can be seen in a parallel circuit. The light globe will glow significantly brighter in a parallel circuit than it will in a series circuit, basically because it's getting the full voltage of the battery. So if you turn on the light globes in your house, you'll notice if you turn on one light globe, it will be bright. And then if you turn on another light globe, they're both bright. One doesn't go dimmer when the other one is turned on. And that tells you that in your house, all of your light globes are actually connected in parallel. So they all glow with equal and full brightness the whole time. The other great thing about a parallel circuit is if I wanted to, I could put a switch in here. So I could turn this globe on, and I could put a switch in here so I could turn this globe on. And I could have both globes on, or one globe off and one globe on at the same time, and it wouldn't really matter. So I could choose to have one off or one on. And that's the same in your house. Again, you can have the bathroom light on and the kitchen light off, or both of them on, or both of them off. Whereas in a series circuit, if I have a switch here, or in fact I've already got a switch, if I have like a master switch here, if I have this switch, if this switch is on, that means current will flow through the battery and both globes will be on. They have to be on. They can't be on or off. If I put another switch in, if I put another switch in over here and I open the switch up, that'll stop electricity flowing, so it won't flow, and that means both will be off. So in a series circuit, all the light globes all have to be on, or they all have to be off, and because they share the voltage, the globes don't glow as bright. Whereas in a parallel circuit, you can turn globes on and off independently of each other, and they all glow with full brightness. And so that's some of the differences between series circuits and parallel circuits.